We're back with 18 of Australia's brightest high school STEM students. This time, the challenges are tougher, the stakes are higher, and the missions are supervised by professionals. They'll be flying drones, cracking codes, and launching rockets, all in a bid to be crowned champions of the ultimate classroom.
We totally got this.
Clear as mud.
Whoa, I need to go back.
Guiding them are some of Australia's sharpest Defence Force minds. Maths legend Eddie Wu and me, Steph Bendixson, back to make sure that no one sets themselves on fire. Expect chaos.
Stop pushing us.
Expect brilliance.
Oh, that's so cool. Didn't see that coming.
Expect the unexpected.
Welcome
to the ultimate classroom. In this episode, our teams tackle a high-stakes and rescue mission. Then it's to the bottom of the sea, where they'll design and code autonomous rovers to clear obstacles from the ocean floor. 2 epic challenges, and only the brightest minds will come out on top. This is the Ultimate Classroom HQ, located on the lands of the Gadigal people of the Eora Nation. And I could not be more excited about the challenges we've got in today's show.
But first, let's meet our incredible STEM students. In the blue team, we have Lara, Aubrey, and Dean.
We are Icy Blue!
I like to solve problems, but in a more creative way.
I like maths and English.
Chemistry is about combining the right elements, and I really like doing that.
And on the green team, we have Kira, Jiayi, and Axel.
My favourite subjects at school are chemistry and biology.
My favourite is English and science.
Software engineering, D&T, and coding, I would say.
We're the Shreksters! Well, welcome teams. I hope you're excited. As always, we're joined by specialists from the ADF, so let's welcome our first mentor from the Navy.
I'm Steph. I'm an aviation warfare officer in the Navy. My job is to command the mission from the sky. I direct the pilot, operate advanced sensors and communication systems, and use that information to make fast, tactical decisions. Every piece of data I gather helps guide the team and shape the success of the mission. It's a role that demands focus, quick thinking, and a deep understanding of technology and strategy.
Welcome, Steph.
Thank you.
Now, seeing what you do in action is incredible. In your experience, what do our contestants need to keep in mind for this challenge?
Well, this challenge takes more than brain power. You'll need teamwork, quick thinking, and the courage to trust your instincts under pressure. That's what we do every day. And now, it's your turn.
Oh, looks like we're receiving a transmission.
This is James from HMAS Albatross. An SOS message has been received. Critical supplies are lost and missing at sea, and it's your job to find them. Initial position report, 33.84 degrees south, 151.24 degrees east. Last seen at time 0900. Good luck.
Okay, teams, this is a search and rescue mission. Using equations based on wind direction and ocean currents, you'll have to calculate where the cargo may have drifted.
From there, it's time to fly using a drone equipped with a magnet.
As you can see, the map is covered in white tokens, and they all look the same, right? But only the tokens in the correct coordinates can be picked up by your magnet.
If your calculations are correct, you can make contact and begin the rescue.
You'll need to fly each cargo token back to your desk one at a time and then safely detach it to earn points. 5 points for each successful rescue.
After the break, we see which team pulls off a heroic rescue and which one might need rescuing themselves.
Oh, it's so stressful. Oh.
Here's your first set of coordinates along with all the info you need to successfully calculate the position of the drifting cargo.
Okay, teams, you have 20 minutes to collect as many tokens as you can. Ready?
Set, go!
The teams are getting stuck into some pretty sophisticated calculations, but fortunately, Eddie gave them a crash course.
Here's the problem. When a ship loses cargo at sea, it doesn't just stay where it fell overboard. The ocean is constantly moving, pushed by currents, tides, and wind. That means you've got to think ahead. If you know where something was lost, when it happened, and the speed and direction of the current, then you can predict where it's drifted to. Now, you're going to get a lot of data. Using that data, we're talking about headings, speeds, times, you're going to then calculate where the objects have drifted to, plot the likely new positions on your map, and then you're going to have to plan a search and rescue mission. Think of it like this. If a toy boat floats down the stream, right, and you want to go and catch it, you don't go to where you let go of that boat. You need to go where it's going to be, and that's exactly what today's challenge is about.
So this challenge we've been given is all about simulating what it's like in Navy search and rescue missions.
Yeah, it's all about using drones to be able to locate missing objects in the ocean. Gave a really big insight into what the Navy does.
This is really interesting because I'm not sure it inherently plays to anyone's strengths. It's just a really good exercise on problem solving and estimation.
Each envelope holds an emergency report with an object, its last known position, the surface current, and the wind speed. The blue team are trying to locate a shipping container. Hey, blue team, tell us what information you're working with.
We've sort of got an area that we think it may be, but we don't know what KT really stands for. We actually didn't know what KT meant.
Yes.
That's
KT means knots, so it's nautical miles per hour, so the cargo is drifting at 2.7 knots per hour.
Not. Oh, that makes everything so much simpler.
All right, I think you've got enough information. Keep working at it.
Well done, guys.
Good luck, everyone.
We've only got 20 minutes to do the challenge.
There's so much to do.
Meanwhile, green team are looking for an overturned dinghy.
If it is pulling it this way, then there might be counter resistance on it pulling it this way. So
Do you have a strategy at the moment?
I think we do.
Yes.
Okay, tell me what you've worked out.
So we're just basing off the surface area and the wind having more of an impact, and the time frame being quite substantial, so it will be travel a further distance.
That's a really good way to think about it. I'd also like to bring up that when you have high winds like this, 15 knots or greater, you get gusts and that kind of thing, and the sea state also picks up a lot. So when you're looking for something like an overturned dinghy, in the real world, it'd be really hard to see because you're going to get those high waves and wave caps and that kind of thing. But it's the right thinking. The wind in this case would affect an overturned dinghy more than the current would. Good luck, guys.
green team.
Let's do it.
Blue team thinks they know where their missing cargo is. They enter the map area, heading for F6. With time counting down, green team also enter the grid, looking for their cargo. This is getting close.
Oh, yeah.
Get the phone.
Oh my god, these drones were kind of hard to fly.
I tried to speak to the drone wouldn't listen.
Bad craftsman always blames his tools.
Wow.
Oh, it's so stressful. Oh.
Teams must get their drones back in the air and find one of the cargo pieces to get a score on the board. And don't forget, the drone will only pick up the token if they're correct.
No, we don't.
Yeah, we got it. Woo! Yeah. Get it.
And turn it upside down.
Green team are still searching.
The magnet was so close to the token, it would go a little bit left, a little bit right at times, and it was just like, oh my god, nerve-wracking.
Yay! Okay, I did it. Come back, Fred. Come back to Carol. We got one. Oh my god. Catch it.
Next, green team need to find a lifeboat, while blue team are still working on their calculations to find the lost cargo.
And that's 5 nautical miles.
A10. Okay, yeah.
Green team have raced through their calculations. I hope they gave themselves enough time to factor in the tricky weather conditions on the report.
Oh my gosh. And
So I'm assuming it's up there then.
Green team aren't having much luck.
we're running out of time. We're trying to find the second token and none are connecting to our magnet. We just can't find this token.
I think we thought the wind took a bit more of an effect than it should have.
Shall we go searching for more?
They're searching nearby sectors to see if they can catch anything there. With time running low, it's certain the next team to score will win.
Left.
Yes, left.
Left.
Just keep going left.
Oh, it's a magnet.
Moved away. We're like, oh!
The downdraft from the propeller blade has moved the target, and green has got their own problems.
We are looking and we are not seeing any signs of this lifeboat.
After the break, we see which team can squeeze in one last rescue before time runs out.
Left.
Yes, left.
Left.
Keep going left.
Oh, it's a magnet.
It moved away. We're like, ah!
We are looking and we are not seeing any signs of this lifeboat.
Green team are going to try another envelope instead, but they'll have to move fast.
Forward.
It moved away.
Yeah!
While Blue haul in their catch, Green rush out to try and find their next target. Congratulations, teams. That was intense.
How was that, green team?
Depressing.
What about blue team? You guys had a mid-air collision.
Yeah. It was
Interesting.
something. I must say.
Green, you rescued 1 token and scored 5 points. But Blue, you rescued 2 tokens and have scored 10 points, which means you're the winners.
Let's go.
Well done, blue team. Brilliant job, but Shrexers are on their way.
On our way.
Blue
team's
team's
coming
coming
for
for you. We did that again.
Well done, blue team, and thank you so much to our Navy mentor, Steph.
Well done, teams, but remember, 1 challenge down, an even bigger challenge to come.
Exactly right. And to help with that challenge, let's welcome our next mentor from the Navy.
I'm Grace, an electronics technician in the Navy. Out here, radar and other sensor systems are how we receive vital information while at sea, and I'm responsible for keeping these systems running at full capacity. We use radar for navigation and to detect vessels and obstacles, even when visibility is low. Add in sonar, thermal imaging and infrared sensors, and we've got a complete picture of what's around us.
Welcome, Grace. It's amazing to see how critical radar and sensor systems are in real-world Navy operations. Why don't you let our teams know what's in store for them this challenge?
All right, teams, you've been tasked with building a deep-sea rover that can autonomously navigate a cluttered seafloor. Your mission? Locate and extract obstacles scattered across the game zone.
You'll build your rovers using these kits. Smart design and coding are key to ensure your onboard sensors get the job done.
Remove the most obstacles and you win the round. 2 rounds, 1 ultimate winner. And Eddie, you know I love a twist.
Well, the catch is that you can't use a remote control to move your rovers. They must be fully autonomous.
I was nervous because I don't have any control over it.
Well, I did Scratch in year 2, and that's pretty much the extent of my coding expertise.
And we just have to sit there and if it wants to self-destruct, let it self-destruct.
Okay, teams, you have 1 hour to design, code, and build your rovers. Are we ready?
Yes.
Let's go. Teams are competing to knock the most blocks out of the circular game zone. Green team are targeting pink blocks, while blue team are aiming for purple. The team whose rover knocks the most blocks out of the circle will win.
First, they need to design and build their rover. Then, carefully attach the sensors. Then it's time to program. These are autonomous rovers, so all their decisions and movements need to be programmed using code.
One of my main hobbies is robotics, and I do a lot of coding both in subjects and in day-to-day life for personal projects. And the practical aspects, I think working with Jai and Kira could come out really well.
Both teams are going really well so far.
Yeah, I mean, the sensors are pretty impressive, and Grace and I got to check out the real deal on the ship HMAS Canberra. Check it out. We're here on HMAS Canberra, and while the weather might be obstructing the view, Grace is giving me an up-close look at some pretty impressive tech that detect the surroundings under any conditions. Grace, tell me what we're looking at.
Yeah, so here we have our navigation radar that we use on board. So this is essentially a much larger version of what we're doing in the studio, but the science is the same. So instead of using sound waves, we're using radio waves. It's transmitted through the antenna, and we get an echo back to the video display that we can see here. Even on days of low visibility like today, you can see everything that's around us.
That's cool. What other kind of sensors do you use?
Yeah, so another sensor that we use is something called the echo sounder. And that's basically the same as like a fish finder you'd have on a boat, and it uses sonar to measure the depth of the seafloor.
Wow, that is fascinating stuff, Grace.
Thanks, Steph. Feels like it could be pretty good inspiration for a lesson.
Now, teams, in the ocean, visibility can be 0. Pitch black, murky, full of obstacles. That's why the Navy relies on sensors like sonar and radar. Now, you might have heard, sonar sends out sound waves, and then when that pulse is sent out, it rebounds off of an object, and it's the echo that comes back. And by measuring the time taken, we can figure out how far that object is. Now, by contrast, today's challenge will see your rovers using computer vision to navigate and respond to their environment. Your sensors will be discerning specific colors to decide what's a target, and then they will act on that information. You'll also need to think carefully about how you place your sensors, because the quality of your rover's visual data will depend on where and how it's gathered.
With their builds complete, teams are now tackling the code and training their rovers to detect their target colour.
You press play on your code, so the code is literally making the robot do everything. We have no control over it.
Okay, teams, these builds look amazing. Construction time is up. Let's see how these rovers rove.
When coding their rovers, Blue Team has made sure their rover is faster and more sensitive to the colour purple. Green Team have gone conservative, not wanting it to run out of the arena.
Who will win? 1 minute on the clock, and go.
Blue Team's rover is straight out of the gate, but it looks like it's targeting pink blocks instead of purple.
I was a bit tense when I was watching it. I was like,
Ooh, that was close. Looks like Blue Team's rover has a block in its sights.
I'm so sorry.
There's nothing we can do. We just have to watch it die.
That's okay.
There you go. While Blue Team attempts repairs, Green Team's rover is heading for its target.
Come on, come on, come on, come on. And it's all very exciting and overwhelming, but our robot was doing the thing it was supposed to do, which was attack the pink blocks.
That's 2 points for Green Team.
Come on, come on, robot, you can do this.
This needs to detect.
30 seconds.
Come on.
Yes, I'm begging.
Oh my God.
There we go.
Okay, back in the centre, Blue Team, and then press go.
Come on, you can do this.
10 seconds to go.
Can Blue Team score some purple blocks before time is up?
Misaligned.
5, 4, 3, 2, 1.
Time's up.
Time is up.
Yes, we're in the lead. I'm feeling so pumped for the next round.
Great first round, everyone.
You've got 15 minutes to change your designs, and then we're back for round 2.
I want you to remember what your rovers are here to do. Form follows function. You're trying to push cubes off of the arena here. Think about another kind of vehicle whose job it is to push other things around, and how you might be able to adjust the shape of your rover in these next few minutes.
But this time you also have to attach these coloured plates to your rovers, which means it might get pushed out of the ring by the other team.
That's certainly changes the dynamic.
Okay, back to building.
We have 15 minutes to rebuild. We have to work fast.
Let's think. We are planning on following Eddie's advice and making it modelled after a bulldozer to really focus on ramming our opponent out of the way.
We added a lot of weight to the back. If this comes after us, they're trying to move a rock. We're cool, calm, collected, and we're ready to win.
And we're cold.
We're cold.
Round 2, you've got 60 seconds. Let's go.
In this round, if a team pushes the other rover out of the circle, they'll get a bonus 5 points.
With a place in the finale on the line, this could be a game changer. But Green Team's rover seems to be
Spinning in place. It's not even detecting the pink blocks like it did at the start. I don't know what's happening.
Oh, Blue Team's rover looks like it's headed straight for the edge.
It swiveled and saw the opposing rover, and it just attacked.
Yes!
Great.
That's 5 points to Blue Team.
Okay, back in the centre, back in the centre.
I hope we still have a chance of knocking some blocks over.
It's spinning again.
I mean, it's just moving around.
Yes!
Blue team scores again with 2 purple blocks off the edge. No points for those pink ones.
Pick it up. Come on, green team, 30 seconds.
30 seconds to go. Oh.
Can green score any points in this round?
Okay, lovely.
It's 10 seconds remaining.
Yes, he's coming back down.
5, 4,
Three,
3, 2, 1. Time's up.
I'm just looking at the wreckage over there.
Yeah.
And this guy's just chilling out, still going.
Well done, teams. What a great demonstration of how important accurate sensor systems are.
We saw some brilliant problem solving today, from clever coding to design tweaks between rounds.
Yeah, there were blocks flying everywhere, but you only scored points for the ones that your rover was programmed to target. So in the first round, the scores were green 2, blue 0. In the second round, it was green 0, blue 2. So that's 2-all.
But blue team, your rover successfully knocked your opponent out of the ring, which means you've won this final challenge.
And with your win in the first challenge, you are off to the finale. Well, thank you so much, teams, and thanks, Grace, for joining us.
Thank you. I had so much fun.
It's been a huge episode full of STEM, strategy, and serious hands-on tech.
Congratulations, Blue Team. We're so happy for you. Over and out from Team Shreksters.
We're off to the finale!
Next time on The Ultimate Classroom, teams navigate a high-tech mirror maze before heading off-road to engineer rover suspensions built for the toughest terrain.
All this and more on The Ultimate Classroom.